Welcome to this webinar session on cloud data migration demystified. Before I go right into this topic, I would like to introduce who our company, Indium Software, and what we do. Indium Software has been there for about 20 years, and we have two major portfolios, QA and digital. As part of our digital portfolio, we service our customers in big data, advanced analytics, product development, which also includes blockchain. Some of our services include big data consulting, data lake solutions, advanced analytics, IoT analytics, data migration, data warehouse services, and machine learning. The other aspect of digital that we also cater to is application services, which includes product development using low-code platforms like Mendix, mobile app development, RPA, and blockchain. We also have a specific service portfolio in cloud related to major players like Azure, AWS, and Google. Coming to myself, I am a senior vice president and I head the digital division of Indium. I have about a couple of decades of experience in servicing clients in specific technologies like big data, advanced analytics, app development. And without much further ado, I would get into the topic for today, which is cloud data migration demystified. Now, cloud data migration can be explained in various things, but I want to address this particular session in answering four simple questions. Why, what, how, and when? So if you take into account cloud migration itself as an activity that most enterprises are willing to investigate and move, one of the key aspects is data migration itself. And data migration comes with different set of challenges, different set of activities that are required to perform in a seamless manner. So let's go right into the deck. So as part of this webinar, here are some content that I'm going to cover. Firstly, Indium's perspective on what data on cloud means. Again, our perspective on what infra options do we have and how do they compare with each other. What are the components that we would migrate as part of a cloud migration activity? And in this particular session, we're going to focus specifically on data migration. Key aspects that we'll touch upon are challenges, migration deployment architecture, our standard data migration framework, how do you schedule migration, and some samples that will help us understand this better. Okay, so the first question, why? So if you look into the aspects that will determine why you would need to move to cloud, some of the key things that you would need to know are what are the key reasons that drive the movement to cloud. So let's look at each one of them, starting with scalable storage. So if there is a need for you to have storage expansion with levels of flexibility that you have been facing in terms of having an on-prem storage, and you have to spend time and money and effort to scale your storage. For example, you have a seasonal impact on your sales, so you would want your storage to scale in such a way that it's not going to impact your time to market. So having a cloud infra with a storage that can be scaled to the levels that you need in GFA of a time is one of the reasons why we would want to move to cloud. The other reasons are, first to start with, accessibility and mobility. So global accessibility and mobility is one of the reasons why people would want to move on to cloud. And having a mobile infra or a mobile setup helps you be flexible in setting up new apps and setting up new regions or setting up new customer base. The third aspect is safety and DR capability. So cloud comes with its own internal features related to data security and also backup and recovery, including disaster recovery, which is built into the solution in each of the cloud vendor provides. Third aspect is cost control. For example, you're on an on-prem solution and you are not sure how much you're going to spend in terms of renewing with hardware. Let's say you are in a bare metal server hardware for about 5 years and you have renewal coming up. You could evaluate whether you would stick with these on-prem servers and refresh them all together, where you need to spend a lot of capex, or you could spread it across years by just paying based on usage. So you could have a better control. Also, you can control based on the amount of time that you would need these servers for, or the amount of storage that you would need to use, along with being billed monthly. So there is a better cost control, and it's one of the key reasons why people would want to move off on-prem to cloud. The next key element is fast implementation. So I'll just give an example in terms of setting up an application on bare metal servers. So let's say you are setting up an application on a single server or a two server application. The time to get your two servers on board and set up applications would normally take a week or two depending upon your vendor who provides the hardware. Let's say you want to do the same thing on a 30-40 large number of servers, then you will have to wait for the servers to be procured, you'll have to wait for the servers to be installed, hardened, and everything. So you will have to wait a lot of time before you even start developing apps. That is something that will really help if you have cloud where you can generate VMs in a few minutes. And these VMs could be available right away for your development and further activities. Last element is security, which obviously has been a concern for cloud, but recently things have improved and there are various security features that even healthcare customers are willing to go to cloud. So let's go right into the next, which is how to compare the options that we have. So let's start with on-prem. Why would companies would still want to stick with on-prem? There are obviously advantages. There are some aspects that you would want to utilize cloud in order to get that benefit. So let's start with on-prem. So as I discussed in the previous slide, startup costs are higher and ongoing costs may be lower. You could start late as and when your budget is ready, but you'll need to build a disaster recovery site, so it adds into your costs. However, the advantage is complete control of your highly confidential information, complete control of data privacy, and you are in complete control of any risks and outages related to your infra. So there are reasons people will look at cloud as an option, and let's look into those. So there are two cloud options. One is a private cloud and the other is public cloud option. So in both options, there are advantages and disadvantages. To start with, so like I said in the previous slide, startup costs are lower and ongoing costs will be higher because of OPEX. So you could control your OPEX by managing your usage. If you have a need to start fast to maximize return on investment, cloud really helps. And like I discussed in the next previous slide, it is definitely flexible and you can scale along with your business needs. It has got built-in DR capability, so you don't have to worry about it. Some other disadvantages are not so positive things are unless you have a full control on your cloud usage, you could fall into the trap of cloud fees getting added up quickly. So you may have to have a better control on your usage. Confidentiality is sometimes a concern with players like healthcare companies, but then confidentiality is now better and could vary between each cloud vendor. But again, it is now better, but confidentiality depends on the vendor. The other aspect that most companies or most enterprises would prefer is a hybrid approach, wherein you have a cloud option for certain aspects of your business and an on-prem aspect for certain aspects of business. The key things about this option are you get advantages from both on-prem and cloud. You could leverage the flexibility of cloud. At the same time, you could have highly confidential information in your on-prem infra. So as a result, you could have a highly beneficial solution of hybrid. At the same time, you can control your cost a little bit as well as control your data security and data privacy a little bit. Now, we don't recommend what is best, but we do recommend what's best for your business need. So we can help you identify the best fit as per your need, as per your return on investment and compliance needs. Let's go into the next slide where we talk about what exactly are the elements of a migration to cloud. So this is a question most people wonder. When you say cloud migration, what do I actually migrate? What are the components that actually should be migrated? So I have divided this into 5 broader aspects. So just to start with an applications that are on your on-prem servers, web server, app server, or like web portals, you have some backend applications running to do your backend jobs, processing, mobile apps. You have any as a service running on your on-prem server that could fall into your applications category. So you could actually move your applications. And any application that gets moved will obviously have some data that needs to be moved. So as part of data, we could move databases, we could move data warehouses, data lakes, etc. The third element is storage. So gone are the days where storage has been a cost concern. Now the storage options are so numerous from cloud that the pricing is really competent. Some of the elements that you could move to storage layers on cloud are documents, pictures, audios, videos, etc. The fourth aspect is communication. So you could move your messaging, emails, reports, statements, etc. into the cloud. Obviously, last but not the least, infra. So you move your bare metal servers, your VMs, your network, your security across to the cloud. So each one comes with its own migration strategy, its own framework, and each one has its own challenges, and it needs to be planned properly with a proper switchover and migration. So the next slide talks about our focus for this particular webinar, which is data migration. So here at Indium, we have a set of best practices, processes, framework, and past experience in dealing with data migration to cloud. And we're going to focus on some elements of these that really help a seamless data migration to cloud. So to start with, I'll focus on the challenges that are faced normally when planning or when performing a migration on-prem to cloud. Let's start with costs. So obviously there is no control on the costs, and let's say you're planning to migrate few terabytes. If you have not devised the cloud data structure or data storage correctly, you could fall into the trap of paying too much cost on storing multi levels of data, multiple places where data is being stored. And also, if you have not designed the data architecture, you may pay for redundant data, you may pay for redundant access, redundant usage. So your cost control could be a challenge. Next element that you'll face is people. This is a culture change. So most people are not ready for change to cloud. People are comfortable with on-prem server. People are comfortable on-prem databases. For example, if you're comfortable with an Oracle on-prem, and if you're looking to migrate to, let's say, Postgres on RDS or MySQL and RDS on AWS, or if you're planning to migrate to Azure DB, people will need some time and change to make this effort to learn the new stuff and be comfortable with the new way of accessing cloud databases or data structures. The next element is speed. So obviously, again, speed depends on the architecture and the infrastructure that is being set up on the cloud. So that is one. Secondly, migration itself of data could take, if it's not planned properly, it could take a week or 2 weeks or up to 3 weeks or 4 or a month or two. So one of the key challenges we have in data migration is not planning the physical movement, not planning the data movement itself. There are options to move through the pipe, there are options to move through physically for various cloud vendors. So speed is most important, because it is being done slowly, then the time to market and the time to switch over is going to take a lot of time, and it is going to be slow. And obviously the timeline to switch over an app which is production in use is not going to be helpful for your planning. So data migration obvious challenge is identifying the proper data movement, and that could actually be done faster. The fourth element is something that comes up in most of the data migration projects, which is compatibility. So there should be a lot of effort spent on the data source to target compatibility, and these challenges definitely show up during testing, during regression testing, during migration. So there needs to be an architecture device to convert some of these incompatible data structures and plug the gaps. And normally people get surprised during the migration deployment. This could be avoided if we can plan it better during the data migration design. Another key element of the challenge that would face is to identify a timeline when we could actually plan your current production system downtime and switchover. And this is a key element, because the production downtime should not be so much that you have a business impact. At the same time, your data migration deployment architecture should be such a way that the downtime is less smooth and switchover is done seamless. So you'll definitely face this challenge, but this can be addressed using proper planning. The last element is data movement itself. I spoke about the speed of data migration, but data movement sometimes could be done slower in order to make sure the right and the complete data is available. So sometimes you plan a migration such a way that data movement cannot be done on the pipe. It has to be done physically, like carrying a box, Azure data box or what, or something like that to cloud, and then physically bring it up from there. So there, the speed doesn't matter, but what matters is probably the volumes of data that you'll need to migrate. So there are various options for data movement. This is a key challenge what everyone has to address while planning data migration. All right, so let's talk about migration deployment architecture. So in this particular slide, you will see like a section towards the left which talks about what are the sources, how do you plan to migrate. The section towards the right talks about how do we acquire this data, how do we ingest into the storage layer on the cloud, and what sort of processing happens, and in general what happens on top of the data. This is from an angle where the data is being used for visualization, but the consumption could be an application or an application web portal or a mobile the processing could be a backend set of jobs. So I just gave an example architecture for somebody who is building visualization on top of your data. So if we start from the left, there are going to be source databases. For example, we just listed a data warehousing type solution, Teradata, Oracle, Netezza. Depending on the volume of this particular source data store, we could do it over internet or we could do it over physical. The data movement over internet or physical will be dependent on the plan and also on the volume of data that you have. So once the data is moved, then it is made available into a landing area in your migrated area on the cloud. And you could specify a landing area for the data stores to be residing before you run the ingestion. Now these migration scripts will need to be built in order to copy over or pull the data from your data sources through the internet or upload the data that is available after physical movement. Once the file or data sets are available in landing, you can use your pipelines to move to your actual data stores on cloud. So these data stores could be table storage, S3, for example, AWS or Blob, or a table storage, or file systems. And then there is another product specific to databases or NoSQL or RDBMS solutions. So if you look at storage layer, there are two components that you could utilize. You could utilize the cloud storages like S3, Blob, for example, Google Cloud Storage, along with some products like Amazon Redshift or Azure SQL DB or Azure SQL Data Warehouse, along with solutions in Data Lake. Could be you build your own data lake on the VMs, or you could build, for example, an ADLS type thing on Azure. So it could be a combination, or it could be one or many. Now, again, this particular example was specific to visualization. So the processing includes some ML, some BI, some automation, which would then feed into your visualization layer. So in this particular scenario, the most important aspect is the first two boxes towards the right, which is data acquisition and ingestion, and identifying the right storage afterwards. So this is how we migrate the data specifically on the data migration side for cloud migration. Most important things to note: one, identify the right movement strategy, identify the right acquisition strategy, identify the right ingestion strategy, and identify the right storage. So we will have to design this in such a way that the architecture helps you perform the migration in a seamless manner. Like I said, on the right side, the processing and visualization could be some completely different. So if I can give an example, let's say you have a web portal running on a few VMs, and this portal uses MySQL, and you would want to migrate to cloud. Your source database could be MySQL on MySQL on your local servers. And let's say if the storage is less than a terabyte. So you could just use some migration scripts and migrate over MySQL, export and import into your MySQL and RDS, for example, if you're using AWS. And the application component itself can be brought over into the VM on the cloud. And the VM would then connect to the cloud storage, which is MySQL and RDS, and you could bring up the application. This can be done pretty quickly because the example that I gave you is a small scale application with less than 1 terabyte of data. But if you're looking to migrate over, let's say, petabytes of data, you need to identify the right data movement, data acquisition and ingestion, and obviously the whole end-to-end solution framework. So here comes the migration framework that Indium has, that we normally utilize for our migration projects. So we can help you with this framework. This framework has been developed with the experience that we have been having in terms of delivering various cloud migrations, specifically on the data side. So to start with, this is a kind of an iterative approach. In general, it doesn't look like an agile, but if you look into it, this is a shorter span, a slightly modified waterfall model, but iterative approach. So if you look at the key steps, so we, as part of the migration framework, we analyze, we understand the migration requirements, we understand the source databases, we also identify the dependencies and feasibility, and also perform feasibility analysis. Once the analyze phase is done, we then go into the architect phase, where we design the migration solution. We identify the test strategy and identify the test planning for the migration. We also do what we call as a migration code design. So this is like a one-time one-time set of code that is used for migration, and we perform design as part of this architect stage. The next stage is develop, where we build and test the migration components, build and test the app, build and test the core and the components. Some of the key things related to data migration are database schema, DB objects, ETL components. We also build migration accelerators and job schedules. The next element is validate phase, which is to perform integration testing from the app to the DB, or from the visualization to the DB, get the users tested through UAT. We also run performance tests to benchmark and verify if it is actually same or better than previous setup. Then the key aspect of this migration framework is migrate stage, wherein we deploy the target database and the code components. We either do a one-time data migration or a parallel run, which includes a DB sync. So this particular scenario is actually identified during the architect stage on how do we actually plan the migration. So one-time data migration could do if we have a small scale application and not so critical. But if you have a large scale application and the downtime itself is really difficult to find, you would want to do a proper test out for a month or two or a week or a few weeks. You would then set up parallel runs on your new environment and your old environment, perform a DB sync and verify everything is running fine on the parallel environment, and then perform a validation and switch over or a cutover. So all these things will be planned and identified during the analyze and architect stage, and we could help you with that. At the bottom, you will see some of the key elements of our migration framework, starting with source databases. So pretty much comfortable with the key commercial databases, open source databases, cloud databases, and now SQL databases. So we can analyze these and perform data migration from on-prem to cloud, from one cloud to another cloud. Right. So some of these databases either have some specific tools, migration accelerators, or we normally build some of these. So that is what is listed in the second box. So if you see some of the accelerators like migration methodology, it identifies what is the source, what are the processes and templates we will need to follow for migrating from one DB to another DB. Sometimes we also use inbuilt tools on the target cloud like a DDL migrator or a source DB analyzer or a mapper. So we also use some third-party tools to help in data ingestion from one source database to the target database. We also have a specific Azure related tools. At this moment, I would like to mention that we are a silver data analytics partner with Azure. So obviously there is some bias here, but it doesn't mean that we are very specific to Azure. As part of accelerators, though, there are specific accelerators in Azure, which includes Azure Database Migration Service, Azure Data Factory. So we can utilize these tools and make the migration itself easier. The next element is our capability in Infra. So we are pretty much capable in delivering migrations from one type of on-prem to cloud, or cloud to cloud, or private cloud to cloud, or on-prem to private cloud, and also hybrid solutions. And obviously the last element is the target databases. This is the list of target databases that we could help as part of our data migration framework, starting from our commercial to open source DB, Azure, Postgres, Redshift, RDS, MariaDB. We also migrate from these various source databases onto data lake like Hadoop, HD Insight, Hortonworks, Mapper, etc. Hybrid data lakes, which I spoke about in the previous slides, we could set up a hybrid data lake with Blob and SQL DW or ADLS. At the same time, we can also do a hybrid data lake with S3 and Redshift, and we can also migrate to NoSQL databases. So in this particular framework really helps to build out and plan a data migration project, and this really gives impetus to your migration needs, and it also gives a better and efficient solution because we have the required lifecycle process for migration, we have the required source database capability, we have the required accelerators, we have the required capability in the target infra and also the target databases. Moving on. So the next key element is how do you schedule migration? So some of the key aspects of scheduling migration is to make note of the impact to your business and also time to market. So these two things drive your schedule. And so the three stages before that you see here are specific to your migration. So starting with pre-migration, the pre-migration tasks include readiness assessment, which is assessing your readiness on infra security, getting the user acceptance test done, and ensuring all the apps that connect to your application and database are tested and ready to migrate. Then you will need to do a test run to be able to identify a go no go for your migration. So migrate data in your test run in prod, validate it, fix if any defects, and then determine the actual migration days. So that's why you see it a little bit slightly inside rather than at the end of pre-migration. Then you have a little bit of time to prepare for your migration. So you start the migration, get the movement done. The data movement could be over internet or through physical. Then you actually do the deployment. So the deployment involves deploying your target DB, deploying apps, can run the conversions from your source target to source database to target database, perform one-time data migration, validate the imported data, then identify a go no go for incremental runs and switchover. There's another key aspect where, let's say if after deployment you do find there are issues, then you would need to evaluate whether it requires a rollback or a forward fix. So that is a key decision and it's part of the deployment stage. Then now that you have done deployment, you will obviously need to catch up and be current on your data. So you will need to enable parallel runs on catch up. You need to run your incremental jobs so your data is in sync with the production or in sync with the current date, and then validate post incremental runs. So then after you're done with this, you're caught up on your data. Then you do post migration checks. So as part of post migration checks, make sure the downstream applications are pointed to your new target DB. And then if you're running on parallel, plan and perform cutover. So this is not a standard schedule, but this is in general a schedule that will help you drive what activities are required for your particular needs. So you could identify this particular high level schedule at the top and then plan dates into it, identify the risks and challenges and mitigate them, and have a detailed migration plan, and then work through the migration with the components that you have. We'll go to the next slide, which is basically talking through some of the samples, and some of these could resonate with your needs. So let's start with the sample. First sample is moving from Teradata setup as source to Azure SQL DW. So if you look at the framework aspect of it, let's say analyze. So on Teradata, you would want to analyze obviously the migration requirements, whether you want to move one schema, all schemas, or few schemas, few business domains to identify whether it's a full-blown migration from Teradata or only few. Then the next step is to analyze the components of Teradata, which includes the data model, DDL, schemas, database objects, BTEX scripts, security, storage, processing capacity, concurrency. Then we perform dependency analysis specifically on upstream and downstream apps that connect to this Teradata database, which includes ETLs and scripts, reporting, analytical models, etc. We also analyze the availability requirements, disaster recovery requirements, backup and recovery. And then if required, perform a feasibility analysis if the target DB is something new. In this case, you could do a small POC to just ensure the data conversion aspects of it. Coming to the architect stage, so we talk about various elements in architecture, specifically with migrating from Teradata to Azure needs a majority of changes. So starting with data model. So if we are sticking with the dimensional model, so we have to identify the changes in data model. We have to redesign semantic layer, identify the migration path. If there is a one-time migration solution for historical, that needs to be designed and architected. We need to architect parallel runs and data sync until cutover. We need to design changes to impacted upstream and downstream apps. We need to identify data mapping between source and target. In this case, it's Teradata and SQL DW. We will need to design a migrator tool for Teradata to SQL DW. The migrator tool could deal with DDLs and also code, BTEX scripts basically. We will need to identify the test strategy, test plans, and scenarios. And also, if there are any new jobs or new pipelines that are required to be built because of the migration, that needs to be designed. And last but not the least, design, backup, and recovery. And coming to the build aspect of it, so this includes building and unit testing, code components, which involves new data pipelines, modifying upstream and downstream ETL scripts, modifying reports and analytical models, data conversion scripts, one-time migration scripts, parallel run, DB sync scripts, DDLs, job schedules. The other documentation elements include release notes, ops manuals. As part of validation, we normally recommend 2 cycles of system integration testing, which includes defect fixes, additional cycles as per test strategy, and followed by user acceptance test. Again, this is 2 cycles at least, and identify the gaps, plug them, and get the UAT sign off, and then perform performance testing to ensure the new setup is going to be at least the same as the old setup. And eventually, the migration stage, which includes the data movement to Azure. It could be through express route network setup or Azure data box shipment, which is physical. And then we follow that with target DB deployments and code components, run the data conversion from Teradata to SQL DW, which includes Polybase for conversion, perform post-migration validation, run parallel runs for if you are planning to switch over at a later date, and then redirect your downstream applications to the new data warehouse, and then plan and perform cutover. So this, if you look into the list of steps this noted, this is like a full coverage of what are the elements related to Teradata and Azure SQL. It could be dependent on your needs, it could be customized, but in general, this gives you a fair idea of what you need to do when you're migrating from Teradata to Azure SQL. The next part of this example is the actual architecture. So if you saw the original framework, they were on the left side, it was a source and data movement. On the right hand side, you would see the various steps for a data warehouse. In this particular example, it's Teradata to Azure. So we're migrating from Teradata either through express route network or through Azure Data Box, which is physical, and then land it into the cloud landing area. From there, you build your migration scripts to move into from landing and be ready for data factory. Data factory is the pipeline which will then move the data from landing to your cloud setup, which could be one or many data stores. In this case, the example is a SQL DW along with blob storage. Internally, Polybase helps migrate from blob storage to SQL DW. And on the processing side, if you have ML, it's Azure ML. If you have a cubes type of environment, Azure Analysis services, all controlled by Azure Automation. And then you have visualization layer, in this case for BI. You will need to repoint all of them to SQL DW from your Teradata to SQL DW. There could be aspects of data format changes and everything. So these come under migration scripts where we do conversion. So the next example is specific to SQL Server and open source. In this particular example, we talk about migrating from SQL Server to an open source database, but on Azure. So we have given 3 options here. One is Postgres on Azure, MySQL on Azure, and MariaDB on Azure. The concept is the same. So from SQL Server, we will migrate the data from internet using express route or Azure Data Box if the volume is high. So migration scripts then moves from the landing area through data factory into one of these databases that you decide. And from there on, the processing and visualization could pick up your data. As you see, there is a small difference from the previous setup. In this case, since I'm using an open source DB, just gave an example of a web app or an application service or a generic application that pulls off of your database. So even Power BI could be one of your consumption layer. This is an Azure specific sample, and while it looks simpler, the key elements here are to decide the data movement architecture, decide the data acquisition and ingestion components, identify the right storage, and then identify the right migration deployment. With this, I would think this gives you a picture of how our data migration framework would help to achieve your time to market on migrating to cloud. If you have any questions, please write to us and we are happy to help. Thank you.